Good morning students. Chapter 8 Gravitation. Now next theory. See, in last lecture we have discussed about if you are given more than two particles, then how to find gravitational force. And yes, gravitational force due to hollow spherical shell of uniform density. Now yes, we know Newton's universal law of gravitation, that is F is equal to G m1 m2 upon r square. F force, m1 m2 masses, r distance, G capital G, it is universal gravitational constant. So what is value of universal gravitational constant and how to find that value we will see today. Okay, gravitational constant G. Okay, we can find value of G experimentally. Okay, from experiment we can find value of gravitational constant. First such experiment was performed by Cavendish. Okay, first such experiment was performed by Cavendish. Okay, so now in this lecture we will see what is experiment performed by Cavendish. Okay, and how to find value of G. You see, it is simple. It is fixed support. From this fixed support, wire, a thin wire is suspended like this. A thin wire. Okay. Now, from this thin wire, a rod AB is suspended, which can easily rotate in horizontal plane. Okay, so yes, there is one wire. It is like this. Okay, there is one wire from fixed point and one wire AB. It is connected like this. This wire AB can perform rotational motion. Okay. Length of this rod AB is L. It is wire, it is rod. Wire, it is rod. Okay. So we will write the statement as shown in figure. A rod AB having a length L is suspended by a thin wire as shown in figure. Clear? Okay. Now, two small lead spheres are attached to two ends of rod AB. Okay. Two identical small lead spheres having masses small m. Clear? Okay. So two small lead spheres identical are attached to ends of rod as shown in figure. Okay. Now another two large lead spheres are brought close to these two small spheres, but like this. If one sphere is here, means on this side, having mass capital M. Okay, it is brought one sphere this side. Then other sphere you have to brought on opposite side like this. Its mass is M. Clear about this? Okay. Hello. You have to bring two large lead spheres near two small spheres, but in opposite direction as shown in figure. Okay. So now when two large lead spheres are placed or are brought close to small spheres. Okay, two large lead spheres are brought close to small spheres as shown in figure. So clear about this? Okay. Now what happens? See, we know Newton's law of gravitation. Each and every object in universe attracts another object. So yes, it is small sphere having mass m, it is large sphere having mass capital M. So there is gravitational force between them. Yes, there is gravitational force between them. But which one experiences the gravitational force? For example, it is chalk and second object is earth. So yes, according to Newton's third law of motion, F12 is equal to F21, means they both exert force on each other. Okay, due to small sphere, force is acting on large. Due to large sphere, force is acting on small. Yes or no? Yes. But which one will experience that force? Smaller one, having mass small. If you drop this chalk is moving in downward direction because its mass is very less than mass of Earth. Yes, mass of. Okay, so remember, whenever you are given two objects having mass difference, the smaller one will experience the effect of that force. Clear? So here, this mass small m, this mass capital M, there is gravitational force between them, but that force is experienced by this smaller one. So it is attracted towards larger one. So force F is acting in this direction. Yes or no? Yes, it is. Okay, now see, M, that distance between them is D. Here also, distance between them is D. Okay, identical situation. So as force acting on this small sphere is F, which is towards capital M. Similarly here, force acting on this small sphere, it is in this direction, F. Any doubt? Okay, so see, here, attractive force is acting on small sphere due to large sphere as shown in figure. Yes, on this sphere, this side. On this sphere, this side. So from figure you can identify some points. See, M distance between them is D. M distance between them is D. So yes, these both force, they are of equal magnitude. From figure it is clear, they are in opposite direction. So yes, the resultant force is zero. Resultant force is zero means translational equilibrium. Means this rod AB is in translational equilibrium. It is not performing any linear motion. Okay, so here I have to write. Here, as shown in figure, forces acting on small spheres have equal magnitude and opposite direction. So therefore sigma f is equal to 0. Rod AB is in translational equilibrium. It is in translational equilibrium. Clear about this? Okay, rod AB is in translational equilibrium. But see again figure. These two forces, equal magnitude, opposite direction, and not collinear. Yes, see in figure, the line of action, they are not collinear. So remember chapter number 7, when you have two forces of equal magnitude, opposite direction, not collinear, they form a couple. Yes, they form a couple, and due to couple, torque is produced. Clear? Due to couple, torque is produced. So see, here it is, as shown in figure. Again I will write, as shown in figure, two forces have equal magnitude, opposite direction, and not collinear. So therefore they form a couple. And due to couple, torque is produced, and therefore due to couple, torque is produced in rod AB. Clear? And this torque, is produced due to these two forces, gravitational forces. It is called gravitational torque. So therefore, gravitational torque, tau is equal, it is force into L. How? Remember, due to couple, torque is equal to magnitude of any one force into perpendicular distance between them. Yes, magnitude of any one force is F. And what is distance between these two forces? It is L. So yes, torque is F into L. Now what is F? Simple, it is F, that is force between small and large sphere. M D. So it is simple. See, it is equal to, it is G M upon D square. Here it is L. So it is gravitational torque, and due to this gravitational torque, now understand, see, due to this gravitational torque, this rod AB is performing rotational motion. It performs rotational motion. Due to this gravitational torque, rod AB performs rotational motion. Due to it, rod AB rotates. Clear about this? Now what happens? See, if you have one arrangement like this, okay, it is wire suspended, this end is fixed, okay, and one rod is connected. If this rod AB rotates, then in this wire twist is produced. Yes, in this wire twist is produced. If you have one string, okay, and rotate both ends of string, then see, twist is produced. In typical Gujarati we says that yes, anda chade chhe. Okay, word chade chhe. Yes or no? Yes. So here, in this case, as this rod AB rotates, in this wire, twist is produced due to rod AB rotates, and therefore twist is produced in wire. Twist is produced in wire, and in a wire restoring torque is produced. New concept. Now what is restoring torque? See, it is easy. It is fixed point. This rod AB rotates. Okay, so what happens? In this wire, twist is produced. Now if you release this rod, it will move in opposite direction, acquiring its original condition back. Yes or no? Yes, it is. Yes, it is. If you have one wire, okay, if you twist that object and if you leave that force, it will again come to its original shape and size due to restoring torque. Yes or no? Yes, it is. Yes or no? Yes, it is. So what is restoring torque? See, this rod AB tries to rotate. Okay, it rotates in this direction. Twist is produced in this string, in this wire, in this direction. So restoring torque is produced, which tries to bring back the situation in original condition. Okay, so twist is produced in wire, and therefore restoring torque is produced in wire, which tend to rotate wire in its normal position. Yes, which tend to rotate the wire in its normal position. And such restoring torque, tau is equal to is k theta, where theta is angle of twist. And K is restoring torque. Per unit twist. K is restoring torque per unit twist. If twist is unit, restoring torque is K. If twist is 2, restoring torque is 2K. Similarly, okay. So yes, it is restoring torque. Tau is equal to it is K. Now what happens here? Gravitational torque rotates the rod AB in this direction, while this restoring torque, it tries to bring back the rod AB in original condition. One tries to rotate, another tries to bring it in its normal position. So what happens? Yes, it is clear. They both are in opposite direction. So at a point, at some angle where its magnitude becomes same, it is in equilibrium. So here in equilibrium means sigma tau is equal to 0 of rod. In equilibrium condition of rod, what happens? So gravitational torque is equal to restoring torque. Yes, they both are in opposite direction. One tries to rotate, another tries to bring back in original condition. So yes, they both are in opposite direction. If their magnitude is same, then it is said to be in equilibrium condition. So in this equilibrium condition, gravitational torque is equal to restoring torque. If I write formula G mn upon d square L is equal to it is k theta. So from this, if you make G as subject, it is k theta d square upon m and L. Simple. You have to make G a subject. So if you make G a subject, it is k theta d square upon m and L. Clear about this? Okay. K, restoring torque per unit twist. It depends on material of this wire. It is known. Theta, you can easily find what is angle of twist. D, distance between small sphere and large sphere. It is also known. M and M, mass of large and small, you know. L, that is length of rod. It is again given. So yes, from this all value, you can easily find what is value of G. Yes, Cavendish also calculated value of G, but from that time to this time, there are some modifications, and right now accepted value of G is 6.67 into 10 raised to minus 11. And we know what is its unit. Its unit is Newton meter square kg raised to minus 2. Newton meter square kg raised to minus 2. So yes, you have to remember this value of G, gravitational constant. G is equal to 6.67 into 10 raised to minus 11. 6.67 into 10 raised to minus 11 Newton meter square kg raised to minus 2. Clear? So it is the whole theory. What is gravitational constant? Clear about this? Again, two types of torque. Gravitational torque, which tries to rotate it. Restoring torque brings back to original position. Okay, so this rod will be in equilibrium at some position where these two torques are in equal magnitude. Okay, so by comparing these two torques, you can easily find what is value of G, that is 6.67 into 10 raised to minus 11 Newton meter square per kg raised to minus 1. Clear? Okay, so yes, it is one theory that you have to remember, and this is it for today.